Hello everyone, let's get started. Welcome to today's webinar, Machine Learning and AI, an intuitive introduction. I'd like to take a moment to welcome our audience from around the world joining us remotely via the CFA Institute website. I'm Richard Fernand, Senior Director, Global Content Professional Learning at CFA Institute, and I'll be your moderator today. Before I introduce our speaker, I have a couple of housekeeping notes. The webinar falls into 3 parts, each around 30 minutes long. We'll pause for Q&A after each section. Please feel free to submit your questions by clicking on the Q&A link at the bottom of your viewer and typing your question in the box. You can also use chat to share comments and to see what others are saying. You can select who you'd like to send a message to by clicking on the drop down next to the to. To get the conversation started in chat, where is everyone joining us from today? Can you take a look at the chat function and just answer what country or city you're from? So as I bring this up, now on my screen, I actually have to click along to the More section to find chat. You might have to do that on your screen as well. So I see Detroit, Oslo, Boston, Cape Town, Washington, Melbourne. So a truly global audience. At the end of this session, there will be an evaluation survey for you to complete. Please do give us some feedback. It will only take a moment. Now, it's my pleasure to introduce our speaker for today's webinar. Sri Krishnamurthy, CFA, is the founder of Quant University, a data and quantitative analysis company, and the creator of the Analytics Certificate Program and the FinTech Certificate Program. He has more than 15 years of experience in analytics, quantitative analysis, statistical modeling, and designing large-scale applications. Mr. Krishnamurthy earned a Master's in Computer Systems Engineering and a Master's in Computer Science from Northeastern University, and an MBA with a focus on investments from Babson College. This webinar is part 1 of a 2-part series, the second being on the 6th of May. In this presentation, Sri will focus on key trends in machine learning and how we go about building a machine learning application. Thank you so much for joining us today, Sri. The floor is yours.
Thank you so much, Richard. Thank you for the kind introduction. Hello, everyone. My name is Sri Krishnamurthy, and I'm going to be the facilitator for today's session. Do you see my screen okay, just before we get started?
Yes, we can.
Perfect. Thank you so much. So I thank the CFA Institute for inviting us. This is the 2nd year we are presenting a masterclass in machine learning and artificial intelligence at the CFA conference / webinar / virtual conference. So last year we had a presentation in the London conference, and it was very well received. So we thought we're going to redo this at the Atlanta conference, and we are now pleased to present this in a global way. And I'm so glad to see all the participants coming from different parts of the world. I hope this is going to be educational, and I hope this is going to be, you're going to get something out of it in the next 2 hours. So the way we have planned this session is over the next 4 hours, that is 2 hours today and 2 hours on May 6th. We want to give you a good orientation on what is AI and machine learning and how does it relate to finance. And my company, Quant University, has been working in the area of AI, machine learning, and quantitative finance for more than 7 years now. And we started out with the mission of educating various aspects of machine learning and AI, and how does it matter to investment professionals in the industry. So without further ado, I'm going to lead you through today's agenda. And please feel free to type in questions. And Richard, if there are any AV issues, we're all working in a different world today. As I mentioned before, we are doing this in a virtual way. So if there are any questions or if there's any problems with the AV, do let us know. That way we can either take care of it or kind of redo some of the portions which may have been missed out. So the agenda for today. So I'm going to give you it in 3 acts. So the first thing we're going to do is talk about the key trends in artificial intelligence and machine learning, and what does fintech mean to all of us as investment professionals. And in order to understand what finance and what AI and machine learning is doing to the whole aspect of quantitative finance and financial analysis in general, we need to kind of go under the hood and understand some of the key principles of what machine learning and AI actually means. So we're going to spend the next part in understanding what are the key terms in artificial intelligence and machine learning. What do people mean by different algorithms which are out there? How do you evaluate these algorithms? How do you put together a whole workflow so that you can understand what's actually happening with respect to AI and machine learning? So once that orientation is done, I'm going to lead with a couple of examples on things you could potentially do with machine learning. And for today's session, I've chosen two examples. The first one is going to be an alternative investment setting wherein an investment manager is trying to invest in a peer-to-peer marketplace like Lending Club and wants to understand what kind of credit profiles do the borrowers would potentially have and how can you accommodate their potential needs and what interest rate should you be expecting these borrowers to pay. And we're going to build a whole machine learning model to facilitate that. The second example we're going to talk about today is this whole area of synthetic data generation, which is pretty much in discussion in today's day and age, especially with COVID-19, wherein some of the scenarios which investment professionals had anticipated early in the year did not turn out the way we anticipated. And now we are grappling to understand the markets. We are grappling to understand the macroeconomic variables, the various variables you need to factor in when you think about management of portfolios. So I'm going to talk about how machine learning could potentially facilitate generation of synthetic data using neural networks, which is one of the methodologies in machine learning. So that's kind of the agenda for today. So the way we want to kind of talk about machine learning is to understand how we have seen the industrial revolution happen. As we saw in the early part of the early 1900s, humans were mostly doing the work and it was labor intensive. And as innovation started to happen, we started gravitating towards leveraging water power, steam power, and we could potentially automate some of these processes which humans would potentially do. And we realized that machines could do things much faster than us. They could actually, we could use leverage and you could potentially do more with less amount of resources. In the second industrial revolution, we started realizing that there were a lot of best practices we could potentially adopt. We were basically thinking about automation and assembly lines and how could you potentially use electricity. And we started building out our assembly lines so that we could factor in best practices and economies of scale. In the third industrial revolution, we started thinking about computers and automation. How could you replicate various processes in a predictable way? How could you basically move the intelligence, what we would potentially do as humans, and bring it onto machines? And the fourth industrial revolution, as it's called, is this confluence of various technologies which are out there, including artificial intelligence, Internet of Things, nanotechnology, quantum computing, biotechnology. So all these different technologies are kind of coming together, and we're going to see a huge revolution. The innovations we're going to see in the next 5 to 10 years are not something we have even envisioned. So the reason why I'm telling you this is finance has also seen a similar kind of evolution/revolution in the last 20 years with technology and innovations in other spaces and making a major influence in finance. Now, if you kind of fast forward, I don't know, probably 2030 is too aggressive an estimate with COVID-19. But if you fast forward 10 to 15 years from now, we're going to see innovations we haven't even dreamt about till today. And that's because many of the hardware and software innovations we have seen to date and the way some of the automation projects are going to continue over the next 10 to 15 years, we're going to see our lives disrupt through technology in various ways we haven't even envisioned yet. So let's kind of get back to understanding the ecosystem of what machine learning has done in the context of innovations in the last 15 to 20 years. WIPO published a report recently talking about how the scientific community has looked at publications in the AI and machine learning space. A couple of things which came out of this study was, you could see the graph on the left, you could see a lot of publications in the area of AI and machine learning. And these are scientific publications, which means that there is a lot of scientific interest in these technologies. Graduate students, the research labs, the professors, the research funding, they are all basically going into a lot of AI and machine learning related projects. The thing about publications and scientific innovations is that when the industry starts realizing that there is business value, you're going to start adopting that within your companies. And then you're going to innovate from a business process perspective, and then you're going to start filing patents. And we've seen a significant uptick in the filing of patents in various AI and machine learning technologies. And if you break it down into segments, you see technologies like neural networks, support vector machines, rule-based learning, deep learning. These are all key machine learning and artificial intelligence methodologies wherein you have significant uptick in scientific publications and also in patent filings. And the trend is not only in other industries, it's also in finance. If you just look up the patent databases, you see a lot of companies like JP Morgan, Capital One, filing patents in the context of AI and machine learning. Now, what does it all mean? So if you have been looking at the job boards, probably not today, or not in the last few weeks, but if you looked at it in the later part of 2019, you were seeing a lot of these companies are interested in hiring talent who are proficient in AI and machine learning. There's been a lot of emphasis on bringing in a new kind of talent, if you will, people who are familiar with AI and machine learning technologies. And why is that so? If you start looking at the ecosystem, so I'm going to give you an example and talk a little bit about the ecosystem. So think about a scenario which actually happened in August of 2018. This was a real story. So Elon Musk sent out a tweet at 9:48 California time saying that he's going to take Tesla private at $420. Now, this was 9:48 California time. And Bloomberg later put out a message on LinkedIn, I believe. And they basically said that at 12:48 Eastern time, within half a minute of, within half a second of actually that message being posted by Elon Musk, that message was already on the Bloomberg newsroom headline. So if you look at what actually happened after that, the price impact had actually happened within a few minutes. So it's impossible for us to consume information which is coming up at such a high pace, and for humans to take that, grasp it, and make decisions. And we're seeing a lot of machines and robots taking automated trading decisions on behalf of us, either based on rule-based systems or machine learning-based systems. Now let's kind of understand, what does machine learning and artificial intelligence actually mean? So I provided a bunch of resources in the slides you're going to get. And this report put out by the FSB defines machine learning as a scientific study of algorithms and statistical models that computer systems use to effectively perform a specific task without using explicit instructions, relying on patterns and inference instead. So what that means is, it's a data-driven methodology. And what we're going to do is use various algorithms to understand these patterns from the data, and then build out models, which will help us in predicting what's going to potentially happen in the future. Now, if you talk about AI, which is interchangeably used with machine learning nowadays, AI actually is a bigger set. It encompasses machine learning, it encompasses rule-based learning. It's basically talking about how can you mimic human intelligence or intelligence displayed by animals, but it's demonstrated by machines. Now, we're not there yet in terms of real intelligence, but we're trying to figure out, can we mimic our behaviors and let our algorithms mimic our behaviors in certain ways? And we're still not there yet, for sure. Now, in terms of talent, who are the people who are making these decisions within financial industries. Now, if you went back 15 to 20 years ago, and when I was a graduate student, many of the topics I was studying, if I wanted to become a quant, were things about stochastic models, factor-based models, optimization methodologies, figuring out the various derivative strategies which are out there, the way to do simulations, distribution fittings. So I was basically focusing more on the statistical aspects, the quantitative finance aspects of things. Today, you see a lot of applications relying on machine learning-based methodologies. And the term data scientist and machine learning engineer is becoming extremely popular. And what that means is you're leveraging newer technologies like natural language processing, robotic process automation, machine learning, and predictive analytics methodologies. Using interesting technologies like computer vision, geospatial analytics, leveraging things like sentiment analysis, using alternative data sets to make decisions. A lot of these methodologies are data-driven methodologies, and these are the newer technologies which are being adopted in the industry today. Now you can see this tectonic shift of the skill sets which you and I were trained with 15 to 20 years ago, and the skills which are in demand today, which makes it important for us to realize that the world is changing and we need to understand and build upon these methodologies as we incorporate some of these technologies into our work practice. Understanding what I hope today's and the session on May 6th is going to at least some of those confusions you may have in terms of what AI and learning is all about. And this introductory session is meant to kind of give an orient in a 60,000-foot view of some of the various and then bring about some of the details in the second session. So what's driving?
Sorry, Sri, it's Richard. Hi.
Revolution. So let's.
Sri, hi, it's Richard. So we just lost your sound a little bit there. Could you perhaps switch off your video, just so we try and optimize the sound?
Okay, try that. Okay. Is it better now, Richard?
That's better. Perfect.
Okay, sorry about that.
Thank you.
Again, please do let me know if there are network-related issues. Again, we're all working in a different world, so some of these are a little bit beyond our control, I guess.
That's great.
Okay, so do you want me to repeat the slide again?
So the sound was good until you had just started talking about the new kind of skill set we were going to need in this new world.
So let me kind of start out again there, and then I'll continue the discussion. Okay, so what has actually happened is in today's day and age, we have this whole confluence of new technologies which are being adopted in our investment practices. And this is augmenting some of the traditional methodologies which we have been using. So some of these methodologies include machine learning, robotic process automation, natural language processing, deep learning, leveraging graph analytics and computer vision, sentiment analysis. Some of these technologies were predominantly used by scientists and the Silicon Valley folks, maybe in the last 10 years. But today, the quantitative finance folks, the financial services organizations are realizing that these technologies are going to add value to our investment practice. And hence, these are being adopted to augment various methodologies which are currently used in practice, both from a fundamental analysis perspective and also from a quantitative investment perspective. Okay, so let's kind of understand a little bit about what's driving this AI and machine learning revolution. So I typically talk about three things which are significantly influencing this virtuous circle of AI and machine learning, as I call it. And the three things are data, smarter algorithms, and then use of hardware. So let me dive down a little bit to get you a better feel for what does this all mean. So first of all, everybody has heard about the big data phenomenon. So there's a lot more data than we could potentially even imagine 20 years ago. The way we are collecting large amounts of data, we've been tracked with the way we do purchases, the way we do transactions, the way we use various technologies, the way we do use different devices, either a mobile device or computers, the way we go and interact outside with various entities, either restaurants or bookstores. We are basically providing a lot of information, and that information is being collected, and you're seeing that this whole set of information, as we call it, is increasing in terms of the volume as we go. In addition to that, we're also collecting a lot of different kinds of data sets. So we are collecting data sets in the context of audio, video, images, social media, graph analytics. So there are a lot of different kinds of information which is being collected. In addition to that, we are seeing the information is coming at a much faster pace. The Twitter example I gave you, we are basically getting information in a millisecond interval, and we could potentially make decisions based on this really fast-paced pace of information. And then we also have concerns about the veracity of information. So you need to have mechanisms in place to understand whether the information we are getting is fake news or is it real news for which you have to make decisions. What that means is there's a lot of data available out there which will influence your investment analysis and work practices. No longer are we in the day and age wherein the Wall Street Journal we would potentially get in the morning is going to make, the moment you read the news is going to help us make the decisions throughout the day. So which means that we need to have the mechanisms to understand what's actually happening and to either take decisions which could be in the benefit of us and our clients, or to minimize or mitigate the risks which are potentially going to be there because certain things happen in the world. So having a mechanism to understand and process the data is very important, and that's where AI and machine learning is going to help you a lot. So when you have all this data, how are you going to process it? So there are two ways in which you could potentially think about processing all this information. And one is to leverage smart algorithms. Because we have so much computing power out there, we have done so much research in the paradigms of building out compute infrastructures, we have technologies which will help us process all these kinds of information. So I teach at Northeastern University in the graduate program, and I've been teaching machine learning and artificial intelligence for more than 7 years now. And most of my students come from a perspective of how do you process all this information and what does it actually mean when you build out these projects. And we have seen the technology evolve over the last 7 years, things like Hadoop, things like Apache Spark, Kafka. So there are a lot of unique and differentiated products to help you process all this information. On the other hand, you're seeing smarter algorithms. And most of you must have heard about neural networks and deep learning in the context of at least AlphaGo and some of the AI challenges which humans have been beaten by machines. So we are seeing a huge interest in algorithms like deep learning frameworks, which are helping us solve problems we'd never think about solving before because of computational and modeling constraints. And what that means is, instead of thinking about linear models, thinking about simple models wherein we think about the world simplistically because we do not have the scope to understand all the complexities of the world, we can now throw in hundreds and millions of parameters into our models and build out infrastructures which will help us scale like we have never thought about before. And what that means is some of these companies like the Amazons of the world, the Facebooks of the world, Googles of the world, they are heavily investing in their infrastructure because they're all running large infrastructures in the cloud, but they're also supporting open source projects. So many of the projects I have put on this particular slide are what are called as open source projects, which means that there is no single entity or an enterprise which is controlling the evolution of these frameworks. It is community driven, and a lot of contributors are either contributing or appending or augmenting the features of these products. And it's also democratic. If there are certain features in certain products which are interesting and exciting, the development community moves towards those projects. So you're seeing a lot of newer innovations happen in the marketplace. In addition to that, we are seeing hardware scaling like we have never seen before. My smartphone is actually much smarter and much faster than the computer I used to use for processing computer graphics in the late 90s. So we have come a long way in terms of hardware evolution, and even a machine you can buy on Amazon or Best Buy has more computing power than probably some of the larger servers which you could potentially have gotten in the late 90s. And today, we have most of these running on the cloud. With COVID-19, we are all realizing that why is it important for us to not just think about infrastructure within our companies, right? So we are all doing remote working, we are leveraging the cloud to run our applications, which means that we could elastically scale. Computation is not an issue. When I started working in computational finance, when I had to think about Monte Carlo simulations, I would set up the parameters, because if I wanted the results by tomorrow morning, I had X amount of time I could run my processes on, and then I could say I can only run 10,000 simulations because it's going to be 9 o'clock tomorrow morning and I need the results. Today, you can run millions and millions of potential scenarios because you have the cloud at hand and you're not restricted by the amount of hardware you could potentially get. And what that all means is we are seeing huge innovations in the industry, and typically you would bucket all these in the context of fintech. And what that means is you have these innovative business models wherein we are seeing that, well, we don't need to be restricted by the business rules we set up 20 to 30 years ago. We could leverage newer business models. We could tap into these emerging technologies. We're not going to be investing or buying some of these technologies. We're just going to be renting them on the cloud. And we could potentially transform the financial industry. And that's what's happening. A lot of fintech business models are leveraging cheap and scalable technologies, and they are disrupting the marketplace as we have never seen before. So you're seeing innovations in payments. The companies like Square and Toast are doing significant innovations and challenging the traditional payment processors. Blockchain has significantly kicked off, and there are various applications. You have cryptocurrencies, you have the futures markets coming up, and you're seeing a lot of adoption in some of these newer technologies. You're seeing things like trading and investing, and you have the robo-advisors of the world, the Wealthfronts, the Betterments, taking a major share of the pie from traditional asset managers. And we're also seeing newer kinds of applications coming up in terms of planning, like retirement planning, education planning, and also incentivizing and gamifying and engaging the millennials to help them kind of get into investments and also think about retirement planning and various other aspects. So, and a couple of other ones like lending, peer-to-peer lending is huge. In one of the case studies I'm going to show you later, we're going to talk about Lending Club and data from Lending Club, which is a peer-to-peer marketplace. This to satisfy the lending needs of borrowers who could potentially not get credit from traditional channels. And also InsurTech, as it's called, you're seeing comparison platforms, underwriting mechanisms, wherein you're seeing a huge number of options available. So if you go to an airport and rent a car, in the past, you had to make the decision then and there on what kind of insurance plan you would potentially get. Today, you could just basically get a basic plan, and then as you're using your car down the street, you could start adding new features based on the location you're going to be going or some of the other additional insurance protections you may want to get when you're on the road. Big data and analytics is huge again, and we're going to talk about some of the key themes in here over this session and also in the next session. And cybersecurity, because we are now relying and trusting so many mechanisms, that's also becoming huge, either in terms of loss protection, identity management, information exchange. So there are a lot of new innovations. So the major technology revolution which we have seen in AI and machine learning is also changing the way we do business. And we are seeing significant pressures in the traditional financial industry because of the newer innovations which are happening. I taught a graduate course at Northeastern University on fintech in the spring, And I was seeing all these students who are traditional, working in traditional asset managers like Fidelity and Brown Brothers Harriman, and they were working on innovative projects. They're seeing some of the challenges the traditional financial industry has. And now that they have the tools and understand the technology stacks well, they're basically putting two and two together, saying, what in case we use this technology stack and we think about change in particular business model and create a new business altogether. So we are going to see a lot of disruption happen in the way we do things. And of course, COVID-19 is going to provide some drivers to enforce these changes. We have seen that, our behaviors have significantly changed. We are all stuck at home and we cannot leverage the resources and the services which we potentially could use in a normal life, if you will. But it's also, as you can see, that our needs are evolving over time. And when we come back to a different normal as we go in the future, we will require newer services and newer products. And some of these fintech ideas are going to come into play. Okay, so now that we kind of understand some of the big picture, let's kind of talk a little bit about some of the use cases which are out there. And I'm going to give you some specific case studies at the end. You're all using AI and machine learning on a day-to-day basis. You probably don't know the Alexas of the world, Google Now, Siri, all these are built on AI and machine learning. And the financial services industry is also leveraging it. Companies are replacing their entire customer service infrastructure by leveraging chatbots to enhance customer experience. So you could put in, if you're using a Bank of America app and use Erica, you're basically using a virtual financial assistant in order to facilitate transactions, moving money from one account to another and doing interesting things. You're also, if you're a traditional asset manager and you're wondering, what does it mean to incorporate sentiments? Companies like Northfield, they're providing data feeds which are leveraging various articles. You could potentially not go in and read 8,000 articles on a day-to-day basis, but you are having companies creating these feeds which will help you incorporate some of those sentiments within your analysis. And also, there are a bunch of use cases. I've provided a few links in here for people who are interested. JP Morgan is investing hugely in machine learning and AI. So 2 years ago, we did a workshop in New York on natural language processing. And we had 6 data scientists all working on natural language processing projects from JP Morgan. Each one of them had a PhD. And they were all there to understand how you could use TensorFlow and various deep learning methodologies to build out decision support systems so that they could digitize all their PDF and text files, which are unstructured data sets which they had, and build an analytical system so that they can understand these data sets better. On the other hand, companies like AQR are significantly leveraging machine learning for quantitative investing, and I posted a link on some of the interesting things they're doing there. And then I'm based out of Boston, and companies like Fidelity in here, they are establishing these centers of innovations, or Sandbox and labs as you call, to bring out these innovations and try it out in a lab setting, figure out whether these fintech business models do really have value in it, figure out whether some of these machine learning and AI technologies are actually going to be usable for some of the use cases they have, and then incorporate them in their investment practices. And then I also saw some of the recent work being done by Wells Fargo. There was an article in Risk talking about how Wells Fargo is using AI and machine learning for performance attribution, but also there are various use cases in the context of trading, from either idea generation to execution. So there are a lot of newer use cases coming up in the AI and machine learning world. So if you look at the startup ecosystem, which, if you're, I live in Boston, so we have some of the best universities in here, like MIT and Harvard. So if you go to the financial district, you don't see just the traditional financial players out there. You do see a lot of startups working on various interesting ideas. Yesterday, there was a the Techstars demo day, and some of the cool ideas came out of those demo days, and you could really see how startups are basically influencing the whole AI and machine learning ecosystem. And this was something the CB Insights guys put out in terms of the various startups which are working in various segments and how they are disrupting the marketplace. Okay, so I just wanted to end this first segment with a slide, because I'm pretty sure everybody in here is interested. What does COVID-19 mean? in the adoption of AI and machine learning in the context of financial services. So some of this is just my take, some of this is based on the discussions I've been having. I just summarized 5 to 6 bullet points. The one thing we should all agree is automation is going to increase. Things wherein humans were involved, which traditionally we have had a lot of processes which were established 30 to 40 years ago, and we're just continuing it because we didn't see a real need for innovation. Guess what? If we are all going to be working from home, at least for the foreseeable future, we are going to be automating various things. We are going to seek services and products which is going to leverage automation, either from a business continuity perspective or to mitigate risk. So we are going to see a lot of automation happen in the near future. Things which we thought were projects for the future are going to be expedited, especially digital transformation and projects wherein a cloud is involved. A lot of times, the biggest friction I saw in the financial industry was this whole notion of how can we protect the data and our IP and our machines internally because we do not want to reveal to the outer world. But if we are all going to be working from home and we have to collaborate, we have to think about infrastructure beyond the confines of physical office space. And that's where the cloud is going to come into play. And we're going to see a lot of use cases move into the cloud. The third thing is use of synthetic data. And there's a lot of debate about what synthetic data actually means. And I'm going to give you some examples at the end of this discussion. But you are going to see a lot of newer data sets being generated. And this is because, if you are thinking about what has happened today and the volatilities and the market reactions and also the change in policy and how it has impacted our investment strategies, there's no way we can just rely on historical data to make decisions. So we have to create a lot of interesting newer scenarios to incorporate into our forecasting and our development best practices. On the other hand, we are also going to see some of the hype and the balloons of AI, which we thought is going to become bigger. They're going to be worsted a little bit. And some of the edge cases, which are not really necessary, we are going to be in a down economy for a while. Some of these nice to have AI use cases will potentially vanish. And then we also have seen a lot of fintechs feel the pressure because the funding situation and how much will they have in terms of their ability to scale up in this down economy. So we are going to see some fintechs vaporize over the next few months. And then there's this whole notion of either black box and full automation versus human in the loop. I think the scenarios are so diverse and so new today that there are going to be a lot more systems wherein a human intervention would be required or human decisions would be required. So we working with AI and machine learning is going to be a lot more closer than we just delegating our work to AI and machine learning based systems. So I think the future is bright, and we are going to make some course, we're going to change course and make some adjustments over a while, but there is a lot of potential in AI and machine learning in the enterprise today. So this was a quick introduction on what AI and machine learning is all about in financial services. We're going to talk a lot more in the next hour and a half today, and also as we kind of discuss some of the core methodologies in the future. So Richard, I'm just going to pause here for a minute and see if there are any questions.
Perfect. There are some. Thanks so much. So if you haven't yet found the question function, just a little Q&A button at the bottom of your screen. But we have some that have come in. So most popular one actually is what coding languages do you recommend that people start to learn now if they want to get into this world? I think a lot of our viewers are interested in furthering their own careers and want to move into what they see as a growing area. So how do they go about doing that?
Sure. So I'm a big believer that everybody needs to at least use 1 or 2 programming languages. Now, it need not be you writing code from scratch. It could be as simple as being a very efficient Excel user, wherein you could work with data sets and you could work with various aspects. But if you are interested in picking up programming languages, start with an open source one like Python. Python is pretty easy to adopt. In fact, we are doing an 8-week course, starting with the premier guys starting May 12th, and Python is the language of choice there. And the reason is it's universally accessible, it's free, you can download it and you can play with it, and within 5 minutes, you can get it going. And when I show you some of the demos, we have built all those demos in Python, and I'll show you how easy is it to pick it up. There are a lot more languages. It also depends on your risk appetite. So if you are a company and you need tech support, if something breaks, you need tech support, it's obviously an open source language like Python may not be the first tool of choice for you, just because you don't have someone to support you, because there are millions of users who are either contributing to Python and building up Python, or you may have to think about a support structure and rely on community help, Stack Overflow or other means to help you build out these applications. So it depends on where you are in your adoption cycle within your enterprise. And ideally, I would say, try out something simple like Python. If you feel that that's going to be a lot of overhead and you need that level of maintenance and support, then there are commercial languages like MATLAB or SAS, which you could potentially go and leverage their support structure. But obviously, there's a cost benefit thing. You have to pay for some of these enterprise products. But start with Python if you're starting new.
Okay, excellent. And a sort of similar, if you like, career-related question. So for someone in their sort of mid-30s or 40s, this person is, I think, who's been in core finance their whole career, and now they're obviously both excited but also perhaps a little fearful about this new world which is coming up next to them. Do you have any advice, any kind of recommendations for how they start to just navigate and understand it?
Absolutely, and in some ways, I'm also in the same boat, right? I wouldn't consider myself as someone who writes Python code on a daily basis. I mean, I understand Python. I could write Python code. I could build out applications. So the one thing everybody needs to understand is you have this wealth of information in terms of experience, understanding the business practices, the relationships, the business value, which some of the technologists don't have. And I was visiting the Silicon Valley in February, and I visited a bunch of startups, and I spoke with a lot of startup folks. The one thing is they're really, really smart. They have the technology background. They come out from really, core universities like MIT, Harvard, UC Berkeley, Stanford, and they don't have the domain knowledge. So the best thing you want to do is figure out if you can partner with folks who can bring in the opposite side of the puzzle in terms of a fintech. There's the fin and the tech, right? So you can think about not just picking up a programming language and just becoming an expert, and 5 years down the lane say, I can write cool Python programs. So that's probably not the right strategy. You may want to kind of combine all the domain knowledge you have and partner with technologists who are really good with technology, and you can see the magic happen there. And most of the successful fintechs have basically used that blend of experience and the right kinds of technology, and the combination of it is actually helping them accelerate their ideas.
Okay, excellent. So it's never too late. That's good to know. So a couple of questions about blockchain and your views on what's going to happen is blockchain really going to represent the future of a lot of underpinnings of the financial system?
Right. So the one thing to understand is actually, wrote a white paper, and maybe through Julian, I can send it out to the audience about, about blockchain and uses of blockchain in the 21st century. So the one thing to understand is blockchain and cryptocurrencies are not the same. Cryptocurrencies use blockchain as a basis. So there are like two parallel threads you can think about in terms of how cryptocurrency itself would evolve as a mechanism and an alternative for traditional currencies and as a digital currency or as exchange of value. On the other hand, you can see blockchain evolve as a methodology of being a distributed ledger to store values, wherein there are a lot of interesting things happen in the last 5 years or so with blockchain. So some of the use cases like tracking diseases, like we are in COVID-19, there have been use cases of using blockchain to trace various drugs and even various aspects in the whole supply chain. Tracking food to table, where was the food of origin, where is going to be, where is it going to be consumed, and if we are going to be expecting pandemics like this in the future, it makes us more cautious in terms of let's track the whole thing. That way we know, if something happens, where can we attribute to the source. In addition to that, there's logistics related. So we are seeing supply chains being disrupted with COVID-19, and people are talking about, well, should the meat processing units be kept open or should they be closed? what's going to happen with milk and dairy, what's going to happen with egg supply. So all those are questions which we are kind of answering as we go, because we don't have all the information yet. But with with systems like blockchain, you could understand where is the whole ecosystem going and what parts of it are stable, and you could potentially track it. So as a store, as a distributed ledger, there's a lot of value. In fact, I would recommend check out the WEF blockchain effort, which they released yesterday. They issued a 244-page report about the potential of blockchain, and it's a very good read. And it's also neutral and very research-oriented, put out by the WEF.
Okay, excellent. That's very helpful. Right, so time for one very last question. Are there examples of disruption, and if you like, misuse in mergers and acquisitions, in M&A, that you're familiar with? And will you come on to that? Because the focus does seem to have been on, if you like, investment decision making and in the retail sort of, if you like, end of things.
Right. So, if you're just talking in the context of AI and machine learning, the M&A, the biggest M&A story recently was NVIDIA's acquisition of Mellanox. It was a $7 billion acquisition. So you could see that there is this interest in terms of NVIDIA bringing its market access and market power in terms of AI and machine learning and the core technologies, and Mellanox coming from the other end where it has a lot of infrastructure related aspects. So you do see stories. Now, are those the norm? You're seeing a lot of acquisitions, done by Google and Apple and Microsoft and Facebook. Whenever they see that there's a pocket of innovation happening in the startup world, these companies take them and then kind of incorporate it into their workflows. Now, do we have the data? Well, it's not big enough, but there are pockets of opportunities in the AI, machine learning space. And there's going to be a lot of consolidation in the next few months too, especially with smaller startups wanting to get acquired by larger companies because they want to grow, and funding is going to be an issue.
Okay, excellent. Right, we better press on to our next module now, I think.
Absolutely.
So
absolutely.
Carry on. Thank you.
I can keep the video open. So if there is an issue again, please do let me know. That way I can switch off the video.
Okay. Okay. Thanks.
Okay. Perfect. So let's get back to the next segment. So this segment is going to be a little technical. I hope I'm not going to bore you with some of the equations. I've tried to keep the mathematics, the statistics, and the equations to as minimum as possible, and with the whole goal of giving you what I call as the under the hood tour of machine learning. Because many a times when you talk about these interesting technologies like AI and machine learning, we're always excited about the technology, but we know so little about these technologies, and we always are scared. Do we just pop up the hood and see what's actually happening under the hood? Or should we just believe what we are hearing? So I want to kind of go down and give you a whole workflow and what it actually means to build out a machine learning application. And this could be a little bit, I have like two goals for you. One is if you are in the stage of your career wherein you think, this is exciting, I want to learn this. And I'll give you some means wherein you could actually pick up tools and you can build out these kinds of things. And machine learning and AI is going to stick around for a long time. And believe me, this is a very good career investment at this point in time if you're learning these new tools and methodologies. If you feel that this is too much, that just learning languages like Python is not going to help you, because there is a bigger puzzle about just first understanding the language and then understanding what all do you need to build out a whole machine learning system. So it'll probably expedite your search for your right partner to figure out who can help you build these kinds of algorithms. And there'll also be options. The ecosystem has evolved significantly so that you don't have to develop everything from scratch. You can potentially leverage services. There is AI as a service, machine learning as a service, and you can potentially leverage the service. But before we even get there, we need to kind of get out of the hood and understand what's actually cooking when you talk about a machine learning pipeline. Okay, so when we talk about machine learning, and this is what I do in my graduate course at Northeastern, wherein these 8 boxes becomes 1 week each box, and we kind of go under the hood and talk about each one of these processes. So let me tell you, if you were working in a company which adopts machine learning, what you typically would be doing. On the top, the first 4 boxes are all data related. And what that means is machine learning is data hungry. You have to provide it with real quality, high quality data so that your algorithms can understand what's actually happening. So in order to do that, you have to think about, how do I get the data? How do I explore and understand the data? How do I clean and process the data? And then how do I figure out what kinds of features or variables are of interest? So that whole process is typically done by data engineering or database teams. And this is ripe for what is called as RPA, or process automation, because it's drudgery, right? 80% of the time you spend in the machine learning workflow is spent on data cleansing. And we are all smart people. We don't want to do that for 80% of our time, just cleaning data, right? We want to do analysis. We want to understand, how does it actually mean? What does it mean for our investment decision making? And that's where there's going to be a lot of automation happening in this whole data processing chain, if you will. Then comes the modeling part. And just because it's an introductory session, I'm going to talk about some of the algorithms which are out there, but there are graduate programs wherein they just focus on the different machine learning algorithms. So do not believe when someone tells you that our tool is just going to have all the algorithms built into it, because that's a lie. There are so many machine learning algorithms out there. Depending on the use case, you have to pick the right kinds of algorithms. And that becomes the job of a designer to figure out what's the problem at hand and how can I solve the particular problem with the data I have and with the tooling infrastructure I have. And in order to understand this whole notion of building models, it's not just a point and click. You need to understand, how do you even evaluate whether the model works or not. So you have to start thinking about some of the practical aspects of adopting machine learning models. Things like, is it a black box? Am I okay with the black box? 6 years ago, I worked with an energy client, and they wanted me to build a machine learning system for load forecasting for energy. And they had a problem wherein they were having an error rate of 10%, and they wanted to reduce that error rate. And they asked me to build out a bunch of algorithms which could reduce the error rate to less than 5%. So I tried out different algorithms, and the best algorithms I could propose to them were all black box algorithms, because that gave them the error rate of less than 5%. Guess what? They said, like, no, thank you. We're going to pay you, but we can't adopt these algorithms, because if we don't understand these algorithms, we're not going to use them. So you need to start thinking about, well, what is your comfort zone in terms of adopting some of these machine learning algorithms out there? And then comes this whole notion of, how do you scale it? When I talked about the Twitter example, guess what? They're not running the whole infrastructure to do trades on a laptop, right? So you need to think about, do I have the appetite to build out the infrastructure in-house, or to delegate it to a cloud provider so it runs on the cloud, or to build out all the clusters in-house to try out all the algorithms and figure out the best algorithms to deploy? So there's a lot of engineering pieces involved when you're starting to think about AI and machine learning. And the biggest mistake people do is think that the Python script or the machine learning script they started out with in a classroom setting is going to be the one which is going to be used in production. So I want to make sure that, as financial professionals, you understand that there is a role of bringing in all this infrastructure together to really leverage the benefits, because 80% of these machine learning projects fail at the design stage, because the moment you go from design to production, you see that there are so many hurdles. So you need to kind of understand the big picture before you jump into adopting some of these processes into your work practices. Okay, so let me kind of go through the tour. I'm going to give you like 5 things you need to know about building machine learning algorithms. And I'll start with data. I'll talk about, how do you set up the goals? Like, what are you intending to do? What are the different machine learning algorithms out there? How do you think about the whole process of building out a machine learning algorithm? And then what does it actually mean to evaluate an algorithm? Now, this is going to be a quick tour. So we have like 20, 25 minutes. So I'm just going to, try to give you the trailer version of building out the whole thing. But if you want to see the whole movie, then obviously you need to invest the time, and we can kind of give you some details on how you can potentially either pick up a book or take up a course or something to enhance your knowledge. So let's start with a simple problem. Let's assume that we are a data set which looks like what you would potentially see in an Excel sheet. For definitions, we typically have these observations as rows, and we have the variables of interest as columns. So this is where you would start out with what's called as a structured data problem. And you would typically have what are called as numerical values and categorical values. And what that means is categorical values are flags, like AAA, AA bonds, whether a particular company is going to default, yes or no. So those would all be in your columns. And then numerical values would be, what's the interest rate, what's the earning of a particular person, what's the temperature expected over the future. So all these are numerical values. And then you could also have the way in which data is structured. The data could be temporal, which means that the continuity of the data is required, especially if you're working with trades and order books, and you're kind of looking at what has actually happened over a period of time. Or it could be cross-sectional, as it's called, which means that you're storing the data independent of the order of observations. For example, if these were transactions done by various customers, and you do have a timestamp, but the actual transactions themselves, you don't have to worry about the order of these. So this is an example wherein you have different stocks. The order of these stocks don't really matter in this particular case. Okay, so the point here is you need to understand the data really well and the kinds of variables you have, whether it's temporal, whether it's cross-sectional, before you start making decisions based on this data. Now that you understand what the data looks like, you have to start defining your goals. Now, a lot of people think machine learning is just a pipeline wherein you take your data and give it to a system and something's going to come out of that pipeline. That's not the fact. You have to be there to decide what you need to do. So in the past, people would try and understand the data really well. So you could potentially, in the statistical world, it's what's called as descriptive statistics, which is to understand the backward looking, what actually happened in the past. Can I observe some of these distributions? Can I observe things like the mean, median, standard deviation, the distribution characteristics of the various data sets? Or can I think about building out something which could be potentially used for prediction in the future? So all these are different goals you need to articulate. If your goal is to just explain what actually happened in the past, you don't really need machine learning. If your goal is to figure out, well, I know what has actually happened in the past, leveraging what has happened in the past, I want to forecast what's going to happen in the future, then you potentially have a machine learning use case. So depending on the point, on the problem you have at hand, you have to start defining what you're going to be doing. So for example, in here, your goal could potentially be, I have all my data sets, and I'm just going to split them into different buckets based on the characteristics of these data sets. And in the machine learning world, there's an algorithm called as clustering, which could potentially be used for doing something like this. And in the next case, in the next session, we're going to show you a case study on using an algorithm called k-means to do clustering of various stocks. On the other hand, if I wanted to learn from certain variables and predict a particular variable, for example, if I'm given various characteristics of a person, their FICO score, how much do they make, what kind of loans do they already have, how diligent have they been in terms of repaying loans in the past, and then I could decide what is the interest rate for a credit card for a loan this person should get using a machine learning based system. And this is basically what's called as a prediction algorithm. And there are multiple algorithms which you could potentially use for predicting whether a person is creditworthy or not. And one of the case studies I'm going to show you later will actually build upon this particular methodology. So to get under the hood and talk about some of the details, it starts becoming extremely complex if you look at the whole ecosystem of what are the goals which are out there. So let's kind of start looking at some of these algorithms and what do they actually mean. So this, again, if you are new to this, do not worry too much about the details. If you're already familiar with that, it's probably a refresher for you anyways. The point here is there are a lot of different kinds of algorithms in the context of machine learning. And you would potentially bucket them as either supervised learning, which means that you have labels you can rely on, which has been recorded in the past, which could be leveraged for building out your algorithms. Unsupervised learning is where you do not have any labels and you're just trying to figure out what kind of data do I have and can I do anything with it, either in terms of summarization, in terms of clustering, etc. If I do not have the data, what do? I start playing games. I build out an ecosystem or a mechanism wherein I can play games and figure out what are the possibilities and learn from these behaviors. Typically, if you are building out systems wherein you're having very little data, reinforcement learning algorithms are typically used there. And in semi-supervised learning algorithms, you have some data and some labels. You're going to leverage that, and then you can kind of potentially use additional unlabeled data sets to augment your predictional use cases and build out certain things. So there is a whole field of study to understand these machine learning algorithms. And in today's case studies and examples, I'll focus primarily on the top right corner, which is the supervised learning methodology. So what does it actually mean to build out a supervised learning algorithm? So a little bit of equation in here. I'm not going to go too deep into the math. The point here is I have a bunch of variables I've observed. And for example, if I'm looking at a person is applying for a loan, a home loan, and they have provided their income, they've provided their credit statements, they've provided all the information. So how will the bank officer decide based on all the information which has been provided? So they'll rely on the past, like a person with a FICO score of 740, earning $150,000, currently renting, having X amount of debt. What will their interest rate bucket be? And then provide that as a potential interest rate for this user, right? So that's basically, that whole process is going to be automated with machine learning, wherein the goal is to figure out this model, which will take the various variables of interest and then provide an interest rate as an output. So that's basically what a supervised learning algorithm is. So what are the choices of these models? And that's where the different machine learning algorithms would come into play. And some of them are things like linear regression, neural networks. We think about parametric models as these are called, and this parameter which could be used to build out.
Sri, sorry, we lost you a bit there. We lost you a little bit there. Could you again switch off your video and maybe just talk about this supervised learning model prediction slide again?
Sure, I will. Sorry. Okay, can you see my screen now?
Can see it, yeah, perfectly, and we can hear you nicely.
Okay, good. So what we're going to do here is, going back to the example I was giving, I'll give you a different example if some of you heard it already. So let's say we are interested in applying for a credit card. So we are providing information as like, what is my FICO score, what's my income, what's my, so I'm providing a lot of different kinds of information and then expecting a particular interest rate. And that's exactly what a supervised learning algorithm is going to do. It basically is going to map the various inputs to an output you have observed in the past. And the whole goal is to build a mapping function or a model which will take my inputs and provide interest rate as an output. So let's see how you can potentially do it. There are a lot of different algorithms out there. And primarily, you will think about two kinds of algorithms. One is what are called as parametric algorithms, things like regression, neural networks. And the whole goal here is to figure out what is the mapping function which I can map my Y to X. Or it could be rule-based systems wherein I'm building out a decision tree to understand how can I ask questions. So think of it as, if you were going to a traditional banker and the banker was supposed to make a decision, the questions they would ask. They would ask, like, what's your FICO score? What's your interest? How much loans do you currently owe? How much do you make every year? So all those questions, they'll kind of go through a decision tree and come out with, well, based on all the information you provided, this is what your interest rate bucket would be. Guess what? That's exactly what a decision tree is. But instead of those questions being determined by the banker, the algorithm is going to deduce what those decision points are based on the data you have provided to it. And that's going to be the whole notion of how a decision tree would be built. And you could think about various mechanisms of augmenting this information with multiple trees and create what are called as boost trees, et cetera, to augment these algorithms. Okay, so there are a lot of algorithms out there. I'm not going to bore you with a lot of details. In the next session, we're going to go deep dive into one or two algorithms so that you get a flavor for some of these algorithms. But let's kind of just get a big picture when we talk about why is machine learning becoming so popular today. Now, some of these algorithms have been there for 20 to 30 years, in fact, more than 30 years now. So why now, right? So we have seen a lot of new innovations happen in the last 10 years or so, which is basically disrupting the whole area of machine learning. And the four areas I've summarized for you here is what are called as deep learning algorithms. And this is basically neural network algorithms, which were constrained with the amount of compute power and the smarter algorithms which were there in the past. We've seen a lot of innovations in hardware. We've also seen a lot of innovations in algorithms. And that's why a lot of companies are using deep learning. In fact, if you've been using Alexa, Siri, Google Now, all these devices, they're all using deep learning algorithms behind the scenes to interact with you based on the information you're asking or providing. The second class of algorithms are what are called as automatic machine learning algorithms. And think of this as, in the past, humans would be assigned the role of decision making in terms of which models to use. And typically what people would do is think about, well, let me try out these 5 or 6 different methodologies, and based on the best result I'm going to get, I'm going to choose that particular model. But if I chose 5 or 6 crappy methods, then I will basically have one method which is probably better than the rest of the 5 bad options I would have potentially chosen. So what automatic machine learning gives you is a mechanism by which you could leverage computational power and smart algorithms to try out hundreds of thousands of potential experiments, and then figure out which algorithm gives you the best possible result. So if you've heard about companies like DataRobot or H2O, or even Python packages like AutoScaler or AutoKeras, so this is primarily using what are called as automatic machine learning algorithms. And the biggest problem here is, some of these are still new, but also they're black boxes. So the interpretability of understanding what these models actually do will be an issue. On the other hand, you have natural language processing algorithms, which are basically revolutionizing the way we think about unstructured data. In the past, if you were training to become a quant, you typically have databases and data stored in Excel sheets. Today, you can leverage sentiments from tweets. You can look at Facebook posts. You can look at opinions. You can look at analyst estimates through various sentiments out there. You could also think about leveraging your internal text-based databases and build various algorithms out there. And ensemble learning is a way of combining the best of multiple models and trying out combinations of those to get you the best possible results. Okay, so there are a lot of different algorithms out there, and there is a nice website called as the Neural Network Zoo, and it gives you some of the various options which are out there on how do you think about building different kinds of neural networks. And some of the terms which we're going to introduce you again during the case study will also be articulated in this website. So please do check out the different neural network architectures which are out there. Okay, so now that we understand that there is the data component, you need to understand what kind of data I'm working with. And then I have to think about, what am I thinking about in terms of my goal? My goal is to figure out a supervised learning algorithm. And now there are so many algorithms. So let's say I make a choice of algorithm. So now, it's like the baking process, right? So you have all the ingredients. Now you need to think about the process. So what am I going to do with all these components? And that's where you have to define what makes sense for you. So you're going to define that I'm going to take the data in here and then do certain processes, then pass it through this particular algorithm. And then these are the outputs I'm going to get. I need to think about whether the outputs make sense and how I'm going to be using it. So that's basically the definition of your process. And there you have to think about things like, well, what kind of transformations do I do with the data? What kind of new columns should I add? What do I do with my categorical variables, et cetera, et cetera. And then you also have to think about how do I test whether my algorithms work, right? So then you're going to say, well, let me split the data into an 80-20 split. I'm going to build a model with 80% and then try out whether my model actually works in the 20%, and then see whether I could potentially use one of these models in the future, right? So some of these process components become handy in terms of figuring out what actually makes sense for you. And that's another important component in your machine learning building process. And the final piece is thinking about performance evaluation. And there are a lot of metrics out there. So as investment professionals, we always go with various metrics, right? So what's the maximum drawdown? What's the standard errors? And we have various metrics. What's the tracking errors? We look at various parameters. In the machine learning world, there are a lot of parameters you have to evaluate. It's not just the traditional statistical measures. You have to think about things like the mean absolute error, mean absolute percentage error. If you're working with categorical variables and classification problems, you have to think about what are the ROC curves telling me, what is the confusion matrix going to look like, what amount of error rates do I have, what are the false positive rates and the true positive rates. So you have to kind of be able to summarize all these metrics to understand whether your models actually make sense. So I'm going to give you a couple of slides. I think it probably makes sense when you get a copy of the slides to just go through these equations. I'm not going to explain these equations for you, but the motivated of you who really want to delve deep into some of these equations, feel free to kind of understand these equations. But the point I'm trying to make in here is, depending on the use case you have at hand, you have to choose the right parameters. If you choose, for example, a metric which you think is the best one for your use case, but when you apply it, it doesn't make sense, then obviously you have chose the wrong metric for performance evaluation. And I'll give you one concrete example as we go to basically help you understand the fact. Okay, so this was a quick 20 to 30 minute tour of what it all means to build out a machine learning application. I hope I did not overwhelm you with a lot of details, but my point here is you have to think about 5 things when you're building out machine learning algorithms. The one thing is the data aspect of it. What do you do with all the data you're going to be getting? Do you have volume? Do you have a variety problem? Do you have a velocity problem? Do you have to think about uncertainty? You have to factor all these things in the context of data. And you may potentially be able to automate some of these processes. The second thing is figure out the goals. And that's where this component comes in, wherein are you building a supervised learning problem or an unsupervised learning problem? What aspects of the algorithms do you need to think about? The third thing is which machine learning algorithms you're going to be using, and that's where this would come in. Am I going to be using a regression algorithm or a deep neural network or an ensemble model or a naive-based algorithm? So you have to make an algorithmic choice on which algorithm to potentially use. The fourth thing is defining the process. You may have to think about all these 8 components, or you may think about, well, I only need like 3 or 4 of these components in my process, and you define what process makes sense for you. And the 5th component is the performance evaluation piece. And that's where you have to think about, well, which metrics potentially make sense and figure out how can I tune my process for that particular metric. And then finally, you have to define how do I take all these components to put together and give it to the hands of the decision makers so that they can input the information and then expect the right kinds of output. Okay. So if you're interested, Microsoft actually put out this really nice algorithm cheat sheet. It's a little dated, but to give you the choice of different methodologies out there. When I talk about these large companies like Google, Microsoft, Amazon, Apple, so these are the companies who are hiring like hundreds and thousands of engineers and data scientists to build out these infrastructures. And a lot of industries are using these infrastructures, and including the financial industry. And some of these technologies may be, how do I put this, may not be talking the financial lingo, but that's where the quants and the financial professionals need to think about, well, does it make sense to use these algorithms for our workflow? Does our data set have the properties which are potentially going to be needed to be considered when you build out these workflows? Things like stationarity, things like whether you have the right kinds of sparsity in your data sets, and all these things need to be factoring in when you're thinking about these algorithmic choices. So I'm going to conclude this second part with what I call as the 5 things you need to know. So if you do not understand any of these algorithms or some of the details I presented to you, at least remember these 5 things I'm going to talk about in the next few minutes. Just to basically let you know that machine learning is not a generic solution to all problems. There are only certain classes of problems when machine learning has shown value, and it's not a hammer when you should not be thinking about using machine learning as a hammer and finding out the nails, which nails to attack kind of a thing. Because things wherein there could be imbalanced class problems, and you could potentially have certain problems wherein you do not have the right kinds of data sets. And in those particular cases, machine learning is not going to be of much value to you. Second thing is, our prototype model is not your production model. And this one I have to emphasize many, many, many times. 80% of the projects fail in the proof of concept stage in companies because when they think about building out machine learning infrastructure, there's a lot of interest in the data scientists and the quant community to try out algorithms, but they all work in experimental settings. And when you take it into production, these won't really add value. So you need to really make sure that you take the testing process from soup to nuts to really figure out whether your models actually make sense. Do I have enough data? Do I have the right kinds of monitoring mechanisms? Do I have I accommodated for all the overfitting, which could potentially be possible? And there were a couple of panels recently on AI and machine learning in production, and people from HSBC and Societe Generale, they were making comments about the whole process of machine learning. And they were saying, well, it works beautifully in a proof of concept setting. When I test it out on my laptop, it works, but when I scale it up in a production setting, it may not really work. So be very cautious about it. If it works in a specific lab setting, you still need to try out the whole thing before you can adopt it. The third thing to notice, even though there's a lot of interest in machine learning, we don't know certain things yet, especially what actually happens under the hood, especially with neural networks like algorithms. So you have to understand the risks of you adopting a technology which you don't completely understand. So that's where certain folks are going to say, I'm only going to go with algorithms we understand and we have the right risk mechanisms to prevent something bad from happening. Or you have to rely on the experts to tell you that we have done the model validation. We can say that with this level of confidence that these algorithms are actually potentially usable. So you have to really factor in the skilled decision making, because we don't know completely how these algorithms work yet, especially when we talk about black box algorithms. The fourth thing is choosing the valuation metrics is extremely important. If you do not choose the right metric, you're basically optimizing on a metric which is not going to be useful for you in a specific case. So here's an example for you. So if you're thinking about a fraud detection algorithm, and if you say, I built an algorithm which is 99.9% accurate, well, in your data set, the fraudulent records will, let's say, is only 0.1%. And if you build a very simple algorithm, labeling all your data points as non-fraudulent, your algorithm will still have 99.9% accuracy rate. But the 0.1%, which was the important class, is going to be completely ignored by your algorithm because you're choosing a wrong metric for evaluation. So please be careful when you're thinking about evaluation metrics, but it has to be contextually used. And the last thing to think about is, well, we're not there yet. When you see and hear a lot of claims about the robots are coming and it's going to replace all our jobs. First of all, there's a lot of hype, and frankly, some of it is vendor driven. Like a lot of companies are pushing technology saying, well, if you're not using machine learning and AI, you're missing out on something huge. There are benefits, either in terms of automation, in augmenting your current models with newer kinds of data sets. But we're not there yet wherein we could just delegate all our work to robots and sit back and enjoy a cup of tea, if you will. So please be aware that human in the loop AI is going to be important. So your skills, your decision making, your ability to really evaluate whether these mechanisms actually work is going to be very important. So there's a lot of hype, but don't believe all the hype. We're just getting started. There's a lot of power, but with a lot of power comes great responsibilities too. Okay, so just wanted to kind of give you a big picture orientation on what does it take to build a machine learning algorithm in the second segment. And I'm going to pause here again, Richard, and take any questions if there are any.
Excellent. Thanks, Sri. So I think we'll take a couple of questions now. There are quite a few questions, some that relate to careers, as we had previously. We'll have a chance to get to some of those questions towards the end, and if not, we hope to answer some of them once the webinar is finished. There are a couple that relate to data. So could you just expand a little bit about what you meant by synthetic data? Because you actually mentioned that in the first section, but data clearly is critical. And a related part of that is how do you ensure your data is not biased? And a great example is current COVID-related data. Data about infection rates is clearly biased based upon who we happen to have been testing. So if you could perhaps address those kinds of questions, that'd be great.
Sure. So we're going to have a whole segment on synthetic data generation when I do the case study in like another 15 minutes or so. So
great. We can leave that then. That's fine.
We'll answer that part of it. Now, with respect to bias, so that's actually becoming more and more of a concern. And that's where the human decision makers are going to come into picture, because machines are not there yet to really understand the aspects of it. Sometimes you think about, well, humans are also flawed, right? Like, we are basically, having data in our systems which reflects our biases, the way we have made decisions. And the machines, and it's again, decision makers' imperative to make sure that, are we going to basically propagate our biases and beliefs to machines? Or should we do better in terms of collecting data from those minority data sets and then augment it with the recorded data so that we factor in the fewer but also important classes of information which may have been inadvertently left out when we collected the data in the first place. But in addition to that, the evaluation metrics also matter. That's where you have to think about class-based accuracies, creating the right kinds of test use cases to make sure that you're factoring in all the required aspects of variety in the data so that you can avoid these biases from propagating. And that's where ethics also comes into play. And we are big believers in AI governance. We do a lot of educational seminars and workshops on AI and model governance. And that's where the model risk department has to come in to, first of all, think about the mission of why are we doing what we're doing, and then also to evaluate what happens when we take these edge cases and how are the systems performing in those edge cases. But it's actually a very ripe and evolving field. In fact, the WEF, again, I want to kind of quote the WEF because they did some good work in terms of talking about AI ethics, and they do address this whole notion of bias and interpretability in those segments.
Okay, excellent. So I think it's probably a good idea for us to press on with your third section now, and if we have time at the end to take a few more questions. So thanks.
Absolutely. So let's kind of go into the presentation mode again. So the next 20 to 30 minutes or so, I'm going to give you a couple of demos, and the whole goal of these demos are to just kind of illustrate the power of machine learning, if you will, and also to introduce you to some of the tooling which is out there. That way you can kind of appreciate what does machine learning bring to the table. And the first one, again, we are trying to create these use cases to leverage the power of machine learning, right? So I'll kind of set up the stage of what does this actually mean when you're thinking about using a supervised learning model to build out a machine learning model for interest rate prediction for a peer-to-peer marketplace. So what we'll do is we'll talk about the case and the introduction. We'll talk a little bit about exploration, and we'll talk about how do we define the problem. We'll do some performance evaluation and talk about deployment. So when we think about credit decisions, when we think about credit scoring models, obviously there are decisions to be made. Should we give up credit or not? Should we increase the spending limit or not? Should we decrease or increase the lending rate? And if the customer already has a portfolio of products, what new products can we give to our existing applicants, right? So these are all typically what are called as credit decisions, which need to be made by bankers. Now, there is this company called as Lending Club, and we're going to use their data as a case study. And for people who do not know Lending Club, it's a peer-to-peer marketplace. Typically, people who do not have high credit scores will go to a peer-to-peer marketplace because they may not have access to traditional credit card or other modes of funding. And the way it works is, for example, let's say I am interested in buying a boat, and I currently owe $50,000 to my credit cards, and I'm maxed out on all my credit cards, but I still want a boat. Someone is coming and I want to buy a boat. So I can go to Lending Club, open up an account, and say, hey guys, I want to buy a boat. I need $10,000 to buy a boat. And investors, who typically invest in what are called as purchase notes, can potentially say, well, Shri is looking for a boat, nice guy. Let me give him $2,000 for the loan, but I expect 30% of interest from him because his potential rate of default is going to be high, considering that he already owes $50,000 to other credit card entities. So if I'm getting married, if I want to buy a boat, if I want to open up my business, if I want to scale my business, all these are potential use cases wherein I can go to a peer-to-peer lending place and invest. So initially what happened was people like you and me would go in and request loans. And then people with high net worth, people considering alternate investment opportunities, would go in and say, well, I trust this person, let me give a loan for 30% or 15% or whatever that interest rate is. And the transaction would happen if the loan amount was fulfilled. But they're also opening up this opportunity to invest to investors who are not just high net worth individuals. It could also be entities. So if I'm an entity and I'm doing portfolio management, and let's say I have a portion of my fund which I can invest in assets which are alternative, and let me consider Lending Club as a potential investment opportunity. And I have to now think about a portfolio of loans I'm going to be investing in and figuring out what's the best interest rate and the rate of return I can potentially get if I invest this whole portfolio of loans, right? So in order to do that, I need to be aware of what is the current going rate for interest rates, right? So what Lending Club has done is they have shared historical data, a lot of historical data, and you can build models, and you can build out a decision-making utility when given a particular profile of a person. You could potentially plug in those numbers and then build out a model which will tell you what the interest rate would have been had this loan been issued in the past, right? So that's kind of the structure of the machine learning problem we are kind of trying to address. And the investors' big decisions are typically, how much should I expect as interest? Is my borrower creditworthy? How much interest would a similar borrower pay? What is the repayment and default rate for a similar borrower? So all these are questions an investor would be asking. So we'll address one question among these in this demo. So you can go and download this data. By the way, we're doing this demo. If anybody is interested in trying out some of these examples, I'll share a link or an email address at the end. Please reach out to us. We can give you access to the platform, and you can potentially try out the experiments on your own. So this data is available on Kaggle. Kaggle is a competition hosting website wherein there's a lot of machine learning data sets available. And this is another great place to go and try out some of your data science and machine learning skills. Data is available for free. The environment is also available. You can try it out there. So you can download the data from there. And this is the pipeline we're going to build. So we're going to get the data, we're going to process it, we're going to do some feature engineering, we're going to build out a model, and we'll deploy it. Okay. So ultimately, I want to build a tool which looks like this. So I want to provide the loan amount, the repayment rate, the installment, the grade of a loan, the employment length, whether I'm renting or own a home, what's my annual income, is my loan or my application verified or not, what's the purpose of the loan, which state do I live in, what's the debt to income ratio, and were there any past due instances. So these are some of the features which are going to be used to really understand whether this person is creditworthy or not, and also what's the interest rate you should potentially be giving. Okay. So let me kind of get into the demo more. So I'm going to share the actual demo platform. So give me 1 second. Let me switch to that. Okay, so what you're seeing now is what's called as Sandbox. So this is what we typically use for our education when we do all our boot camps and courses. So what you're seeing now is this credit risk example. So what we have done is we have built out this app, and this app is basically built in Python. And what we have done is we have built out 3 algorithms: neural networks, linear regression, and random forests. So the examples I gave you. So if I provide certain amounts, a specific term, what is the installment I'm ready to pay, what kind of grade and subgrade of the loan it is, and then what is my employment length, whether I own or rent, what's my annual income, and then whether I'm verified or not, what's the purpose, what state do I live in, and then what's the debt to income rate, and then how many past due instances do I have, and then inquiries in my credit history in the past 6 months, and whether my prior loan was approved. So if I want to choose an algorithm, so now what actually saying is it used this neural network algorithm and said that you are going to get 18% as the interest rate. So how did we get to 18%? So that's where we're going to kind of go under the hood and look at the actual algorithm, if you will. So let me show you that for a second. So this is typically what we do when we build out our algorithms. So we basically have the Python code, just to give you an illustration on how these processes were put in place. And this is what is called as a Jupyter notebook. And what that means is it can run Python code. And I'm going to show you a couple of examples on how it would look. You don't have to understand it, but just to give you an illustration on typically what a data scientist or a machine learning professional would do with the data given out there. So in order to build out that exploration with the data, as I mentioned before, so we typically had what was called as the exploration aspect of the data. So when we talked about exploration, so we typically have the data coming in, and Richard, can you hear me okay?
Yeah, perfectly.
Okay, perfect. So I just want to make sure the audio is still okay. So what we do is we explore the data and we kind of understand the statistical aspects of the data, right? So what kind of numbers do I have? What kind of categories do I potentially have? Maybe we evaluate some of the correlations in the data. We try and understand the categorical features of the data and how many variables do I have, how many numerical values, and what are the statistical aspects of the numerical values, what kind of distributions do I potentially have. And this is where your machine learning skills would come in. Because for example, if I am giving a loan and I figure out that the loan amounts could be anywhere from very close to 0 to close to 40,000, as an investor, I have to think, well, what kind of returns can I expect and what kind of loan amounts do I potentially need to make? And then maybe my risk appetite would tell me that I will only loan amounts from $0 to $5,000. Or if I'm loaning, providing loans between $20,000 and $30,000, this is the segment I need to use to build out my machine learning models. So your data exploration tool will help you kind of understand where in the spectrum of the data you've already collected you need to focus on, so that you can filter in those data sets to build out your particular models. Okay, so this is another example when which shows this whole distribution of annual incomes. So maybe you're going to think about, well, I'm not going to give loans to someone who's making more than $200,000. And the prime reason there is I don't want to have prepayment risk. Someone who's earning $200,000 and asking for a loan of $5,000, first of all, the data may be fraudulent. The application itself may be fraudulent. On the other hand, there's a high prepayment risk if the if the loan was actually a legitimate loan request. Because this person makes a lot more money, and then potentially in the next few months, once their liquidity situation changes, they may just repay back our loans and not pay, and then I have to figure out, where do I need to invest my money again? So all these are decisions which will help you kind of understand what data sets you do need to focus on, what kinds of distributions do you need to understand, and how do you go about trying out your best possible data sets and filtering your best possible data sets. Okay, so this is one aspect I want to emphasize, that it's sometimes lost when you think about building out machine learning problems, that you have to just focus on the algorithm. It's not always the algorithm. A lot of time has to be spent in trying and understanding your data set. Okay, so the other thing I want to also tell a little bit about is when you think about building out models, there are a lot of different hyperparameters which you will have to think about. And that basically means that you have a lot of levers in your data, and then you have to figure out which levers are the right levers. So typically when you build out your algorithms, you have to make a lot of algorithmic choices. And this is where your experimentation would come in, wherein you really have to understand what each one of these actually mean from a decision-making perspective. And this is where experts would come in. So if you are thinking about adopting machine learning, it's not always the case wherein you just choose an algorithm, use the default parameters, and provide your data set, because you will end up with suboptimal performing algorithms. You will have to really fine-tune your algorithms, and you need to really understand what these algorithm parameter choices are. And that's where I spend a lot of time as a practitioner trying to figure out the best possible choices of parameters to make sure that I get the best possible results. Just to give you an illustration of why that is important, if I choose, let's say I built a very simple linear regression algorithm, I chose some default choices, and let's focus on one particular metric called as a mean absolute percentage error, which is my error metric to say that I'm going to expect a 20% error in my outputs. It's pretty bad. If I'm expecting 20% as my mean absolute percent error without fine tuning, it's pretty bad. But if I use different algorithms, for example, when I use a random forest algorithm, I could drop the error rate down to like 6%. On the neural network spectrum too, I could potentially drop the rate down to around 6%. So just by changing the algorithm, I'm able to now reduce my error rate from 20% to 6%. So I'm going to start showing you some things which you're going to be really surprised. There's this whole framework of automatic machine learning algorithms. And we just did a study of using the same data set, but trying out different algorithms. And when we tried out different experiments, some of these automatic machine learning algorithms would reduce the error rate from around 20% for linear regression to close to 2%. And you can discuss about things like overfitting and whether it's explainable, et cetera, et cetera. But the point here is you can see a whole distribution of potential error rates just by a choice of algorithm. And the machines are not going to give you the best possible algorithmic choice. It's the humans who have to make the decision on which algorithm should I be using. And that's where the knowledge of the whole ecosystem and what's applicable to our use cases and the risk aspects need to be factored in. So ultimately, once I have made my choice, I figure out like, here are the various algorithms, and I choose my algorithms. What I typically do is I take my algorithms and then build out a front-end application which looks something like this with the help of my IT team, and then plug my algorithms behind the scenes. So the next time I'm providing these inputs, the model, which has been fine-tuned with the right kinds of data sets, with the right kinds of parameter choices, will use the model I have chosen to do my prediction. So this is just an illustration on how machine learning algorithm will actually be realized in practice. Okay, so let me illustrate. I'll take some questions about this after we complete the presentation. But let me also show you the next case study. The next case study is about synthetic data generation. I believe there was a question out there. So let me kind of set the stage on what it actually means. So one of the biggest challenges when we're working with machine learning frameworks is that we do not have all the scenarios played out in the past, right?
So that's where we have to think about scenarios which are potentially extreme, but also plausible. And we are seeing that in the COVID-19 situation, wherein many of the machine learning algorithms are failing because it has been built predominantly on historical data sets. And the scenarios we are seeing today, oil rates going negative, or we're seeing like a Six Sigma kinds of a situation in terms of market drops, or 10-15% increase or decrease in stock prices in a single day. But we have never seen those kinds of things before. So all those are scenarios which are playing out, and you have to build out algorithms which could factor these extreme scenarios. Secondly, when we work with data sets, there are a lot of times you're working with dirty data, and you may have to think about filling in with expected values of sorts, wherein it doesn't change the statistical distributions of the data, but you can still work with missing data. So that's another potential use case. And the third use case is whenever there are privacy concerns, or whenever data is sparse, you do not have all the data sets, especially when we're talking about things like bias, you have to incorporate with fewer examples, larger examples which you may have to create in order to make sure that you have a rich variety of data sets which could potentially be used for training out your models. And examples being imbalanced data classes, wherein you have small samples of rare classes, and you have to think about increasing those rare class problems into larger data sets for your algorithms. So that's where your synthetic data generators would come in. And many a times it's also used for automating and reducing human efforts. For example, some of the times labeling itself is an extremely human-intensive task. So you actually have companies which are, and especially there are tasks which larger companies outsource to other countries, wherein either it's labeling images or adding tags to specific data sets. It's all done by humans, and it's computationally expensive. So that's where there's a lot of interest of using machine learning for synthetic data generation. Now, this is becoming a very interesting use case, and there are a lot of algorithms out there to help you build out these kinds of platforms, if you will. One of them is what's called as a variational autoencoder. It's kind of a neural network. And another one is what's called as GANs. And for the purpose of this case study, I'm just going to focus on one of these algorithms, and that's basically what's called as a GAN infrastructure for neural networks. And on the right side, you see what a GAN would look like. Basically, what's actually happening in here is we are creating two networks. One is generating fake data, and another one is acting as the police to differentiate between a fake or a real. And the goal here is to train both these networks in such a way that the fake data generator becomes really good in generating fake data, which is going to be so real-like, and the discriminator is going to be so good in terms of differentiating between the variety of fake data and the potential real data which is coming in. So once you go through the training process using a neural network, then you have an ecosystem now wherein you could potentially use the fake data generator as a synthetic data generator, so that you could create real data sets which have the properties of real data sets. So that's kind of the big picture on using GANs. And there are multiple use cases, and we've been experimenting with various synthetic data generators as a part of the platform. So I'm going to show you a couple of examples. One could be for the loan example I told you for the credit data set. So for example, let's say I have very few records of someone who wants to buy a boat. Then I could potentially use a synthetic data generator to augment my data sets with more records of the kinds of loans which potentially could have been issued for someone who is buying a potential for buying a boat. That way my algorithms have seen more of those samples so that it could factor it when it's kind of building out its model. The second example is a synthetic sales data generation tool. So this could be if you're a fundamental analyst and you're expecting certain businesses to be cyclical, and now you are looking at a Macy's or a Best Buy or any other retail store, if you will, and now you have to factor in what kind of trends can you expect in terms of sales. You are creating estimates on specific metrics for this particular company in the future. Maybe you're going to plug that into your discounted cash flows, but you want to generate multiple scenarios on what's your most optimistic scenario, what's your pessimistic scenario, and you want to create these scenarios. So that's where you could potentially use synthetic data generators to create these kinds of alternative scenarios. And for the demo purpose, I'm going to show you a VIX data generation tool. And here the goal is, obviously, the VIX is the CBOE VIX indicates the volatility in the markets. And now we are trying to figure out like what kind of volatility we are going to expect in the future. So we're going to train our model using this GAN architecture and then figure out, well, if I did some synthetic data generation in the future and do X number of simulations, what kind of distributions do I potentially see? And I could potentially augment my data analysis with some extreme scenarios I've observed, or at least categorize some of these scenarios and later. So let me show you the last demo in a bit. Give me 1 second, let me switch my screen. So this was the interest rate predictor demo we just talked about. So let me just close a couple of windows for you in here. So this is basically the training platform we use when we do our educational courses. So this is the example I was kind of talking about. So the Q synthesize. So this is the WGAN, which is using generative adversarial network. It's what's called as a Westerstein's GAN. So we have used this particular architecture to build out our example. So here, the application, I'm going to show you the sales app for a second. So this is the synthetic sales data generation for sales. So you can see that this is like the base sales. And what I could do is change the trend component to a negative. And then once I apply this negative trend, you could see that the sales trend actually goes down. So I could choose the trend factor, the seasonality factor, add some noise as Gaussian noise. And here this was used in, I taught an algorithmic marketing class earlier in the spring. So I actually built this tool to help my students to think about the influence of advertising on sales. And we were thinking about like, well, what in case you add radio advertising? What in case you add TV advertising? What does it actually mean? You're seeing that the advertising industry has been severely hit. Companies like Coke have stopped advertising, if you will. So when you have retail establishments already closed, advertising also is going to take a hit. So we are thinking about, well, what does it mean for various products and what does it do for their sales? And this is a scenario generation tool, which basically illustrates how it could be done. And then another example to show, this is the VIX data generation example I was just telling you about. Okay, so this is basically what's called as TensorBoard, which will tell you the status of how good your training is. So let me dive directly into the simulation part. And in the simulation part, we have just used the CBOE data and we have simulated, this was our network architecture. You can train the network. The training usually takes a little bit of time, but using the model we have already created, we created 10 simulated scenarios. We actually have like 1,000 scenarios, but we sampled like 10 scenarios. This is like the histogram of the various observations. This is like the distribution of the simulation as of this particular day. Then I mentioned a little bit about unsupervised learning. We use these scenarios and we use k-means to cluster these scenarios. And then I could have like a bucket of different scenarios, and based on the situation I envision, I could use those scenarios in my analysis. I could also do what is called as hierarchical clustering, which is another class of algorithms in the unsupervised category to basically look at a whole tree of potential possibilities and then figure out like which potential clusters belong to which particular cases. So there's a lot of power in machine learning, especially from an analytical perspective. But when you see final products, you have to decide what actually makes sense for you. Do you have to think about building out things from scratch? Do you leverage established machine learning vendors and leverage their services? Do you use machine learning as a service? For example, companies like Google and Amazon have text APIs available, which will do things like translation, sentiment analysis, document summarization, et cetera, and they'll provide it for you. So this is just an illustration of some of the clustering-based scenarios, and then these are clustering comparisons. And then you can also download the data to figure out like the different scenarios which are out there. Okay, so just to give you an illustration of the possibilities with machine learning. Okay, I think we have 10 minutes left, so let's start wrapping up. So in today's session, we did it in 3 acts. The first part, I focused on the key trends in AI and machine learning and what does it mean in the context of fintech. In the second part, we went under the hood, understood the whole pipeline or what it actually means to build out a whole machine learning application. And we talked about the various stages and how would you take the data from raw data to pre-processing, to feature engineering, to building a model, to choosing the right kinds of algorithms, to doing performance evaluation, and then building out applications for deployment. As a part of illustrations, we looked at 2 examples. One, factoring in the interests of an investor who is investing in a peer-to-peer marketplace, and then building out an interest rate predictor using machine learning techniques. And there we chose multiple machine learning techniques like random forest, neural networks, regression. And we also understood the power of automatic machine learning algorithms. And in the second example, I illustrated one use case of using a GAN neural network and used it for building out synthetic data generators so that you can understand how the VIX scenarios could potentially be in the future. In addition to that, I also illustrated how to do a sales generation tool in order to figure out the various components so that you can do some prediction of some potential sales scenarios in the future. So that's kind of the goal for today. So if anybody's interested in trying out some of these examples, send us a note to info@qsandbox.com, and we'll have someone on our team reach out to you to help out with setting up a demo for you. Second thing I want to note is on May 6th, we're going to continue today's webinar, and the focus there is assuming that you have already gone through the introduction. We'll focus specifically on unsupervised and supervised learning methodologies. We'll talk a little more about time series analysis, cross-sectional data analysis, and we'll talk about some of the frontier topics like anomaly detection, natural language processing, reinforcement learning. How do you think about risk in the context of machine learning and AI? And also look at model governance, interpretability, and model management. And we'll also have like 2 case studies. One is on machine learning for trading and investment management. And the second one is a natural language processing case study on using Edgar data, Edgar filings data, and building a sentiment analysis network using that. So I'm going to illustrate that particular use case. So you have the link there if you haven't signed up already. And I also generated a QR code for you if you're a mobile person. So please do register. And if you're interested in kind of getting a bigger than a webinar kind of a setting, we're actually starting an 8-week course. And I have provided a link for you on the slides also. That's starting May the 12th. But we're doing a Python prerequisite which starts this Saturday and the next Saturday. So you have this opportunity of doing a 10-week course on building out the whole building blocks of machine learning and AI. So that's available to you as an alternative source. Okay, so I think we're running out of time a little bit. So Richard, I'm going to pause here, and I'm going to hand it back to you.
Perfect. Thanks so much, Sri. So yeah, we have a few questions. Quite a lot of questions have come in, which actually you've just answered. So people were asking about, what could they do before the next session. So I think you've addressed that. If they get in touch with you, then to use Sandbox, then you're able to provide them with some assistance and some practice before next session, which is fantastic.
Absolutely.
So in addition to that, so you presented lots of different if like techniques within machine learning.
Mm-hmm.
In the financial services industry right now, is there one of them which is kind of dominant or hot? So for instance, is it deep learning? Is it ensemble learning, neural networks? What is the thing which is hot right now? Or is it really just a question of the right technique, the right kind of usage?
Sure. So let me answer the question kind of categorizing the potential users, right? So you can classify the users into 3 buckets, at a very high level. So the first class of users are, I would classify them as novel users. They're very new to machine learning. They do not have the in-house expertise in building out machine learning systems. And they are trying out machine learning for the first time. And I don't know if the video is going to still work. I'm going to try and start the video. I've stopped sharing. I think maybe it says that I'm not able to share. Okay, so let me. Okay, perfect. Okay, so do you see me?
Yep.
Okay, perfect. Okay, so the first class of users, novel users, they're new to machine learning. The second class of users have a strong quant team. They know what they're doing. And they're bringing in data science and machine learning expertise. Okay. Third class of users, they are companies like JP Morgan or Bloomberg. They have the core practices, but they're also now trying out the frontier areas, right? So the first group of users, they're predominantly going into tools like automatic machine learning, point and click tools. Let's just kind of give it the data. Let's see what comes out. Let's see if there's value in it, right? The second class of users are actually the more mature users, wherein they already are quants. They have a baseline on what actually works for them. Now they're thinking, well, if I bring in machine learning as an alternative way of modeling, can I enhance the value of what I'm already doing, right? So there you have traditional methodologies like regression, et cetera, but now they're adding things like ensemble learning, potentially also deep learning, right? Natural language processing, using alternative data sets. So all these are becoming interesting for them. The third class of users are saying, well, we don't know whether we're going to use it in production today, but let's try it out. Maybe there's some IP in it. Maybe we are going to realize some new aspects to it. And those are people who are not talking, because the moment they start talking, the value of that particular methodology is going to start diminishing. But they are trying some of these frontier use cases, potentially leveraging hardware, accelerated hardware chips, or using deep learning and doing research. In fact, I was seeing a bunch of patents. That's a very good place to look at. If you go into the patent database and start looking for financial companies and see their patents, it basically tells you the kind of work they're doing, even though you may not really see those in a Wall Street Journal like setting. And I was kind of seeing these really cool synthetic data generation patent filings by various companies, not to be named, but just to kind of talk about some of the innovative things they're doing. But deep learning is definitely getting a lot of buzz. I'm not sure if a lot of practical and production use cases are there yet. A lot of people are still trying. They have goals, but they're not fully operationalized yet, is what my feeling is.
Okay, excellent. Here's an interesting question. So about, I think, kind of training your algorithm. How do you know whether you have enough data to train your algorithm?
Yeah, that's a loaded question, and I'm afraid I don't know the right answer. You will never know whether you have the right amount of data. The way to look at it is, when you think about your performance metrics, right? So if you have a balanced class problem, and what is the risk at hand if you don't have a lot of data, right? What kind of error metrics can you live with? Is it generating enough value for you to even consider the limited amount of data you potentially have? So that's the methodology, and there's a lot of human involvement to really figure out, do I have enough data? Do I need to go and collect more data? Do I use synthetic data generators as a proxy for the data I'm missing in my ecosystem? Can I potentially live with smaller data sets and use algorithms which can work pretty okay with smaller data sets? Right? But in general, machine learning is data hungry. It requires a lot of data to really get good results. So if you do not have the data, in fact, I actually had a funny story to tell you. One of my students went on a summer internship, and he was very excited, and he said, well, I got an internship at this startup which is predominantly using machine learning, and they don't have any machine learning expertise. They're bringing me in. Thank you, professor, for the nice class. And I said, fine. And a week later, he calls me. He says, well, they don't have any data yet, and they want me to start building out the algorithms, and they said the data is going to come. Well, you can't do anything without data in machine learning. So you got to start with having good, high quality data, and then figure out what you can potentially do with those data sets.
Okay, excellent. Well, I think we probably actually have to end our questions there now. Thank you so much for your insights, Sri. Really appreciate it.
Oh, this was a pleasure.
To all of those who joined us online, thank you very much for your time and your attention. Please do fill out the review form you'll receive just after the end of this webinar, and do join us on May the 6th for the next session. So she's going to give us a very interesting taster of what's coming up. We will post the link actually, so it's clear. In fact, it's in the slides, but it's clear. So how to get in touch with QU Sandbox to get that environment up and running if you want to have some practice prior to the next session. But thanks everyone for your participation, and we look forward to seeing you again on May the 6th.
Yeah, thanks so much again. And I'm seeing participation from around the world. Happy to connect with you, even if it's virtual. And please do stay in touch, and allowed to get some questions from you, and allowed to be in touch. And hopefully see you on May 6th. Thank you.
Great. Thank you. Bye-bye.